What's up everybody? Moving on to the next example for the change of variable strategy for solving limits. I'm going to go through the same steps to solve this limit here that we went over in the overview video. If you haven't watched the overview video, I would highly recommend you do so before going over this example, because in the overview video I go through these steps in a lot more detail. This explanation is still going to be pretty detailed, but I'm not going to take my time as much in explaining each of these steps. So make sure you watch that overview video before watching this example. So in this particular example, we got the limit as x approaches 4 of the square root of x minus 2 all over the square root of x cubed minus 8. First thing we check with limits, can we make a direct substitution? Well, if we sub in 4 for x, notice in the denominator how we'll have 4 to the power of 3, which is 64. The square root of 64 is 8, and then 8 minus 8 would be 0. So we got a 0 in the denominator, so we can't just make a direct substitution, unfortunately. The next thing to notice is this expression here, the square root of x cubed. If we change that into a rational exponent, it's going to be x to the power of 3 over 2. And because that rational exponent is something other than a half, we know that we're going to have to use the change of variable strategy. We couldn't tell that we can use the change of variable strategy with just the square root of x, because remember, a normal radical, we can also use the rationalization strategy. But because we have this expression here, the square root of x cubed, and that rational exponent is going to be x to the power of 3 over 2, we know that we have to use change of variable. So let's go over the steps. The first step is we have to transform all the radicals in the limit into rational exponent. So we take the square root of x, change it to x to the power of a half, and we take this square root of x cubed and change it to x to the power of 3 over 2. So this expression here, the square root of x cubed, that's the same as x to the power of 3 to the power of a half, right? The square root is the same as to the power of a half, and then we could just multiply those exponents and we'd have x to the power of 3 over 2. Hence what I got right there. Now the second step, we have to introduce a new variable, and the new variable we're introducing is u, and we're going to let u equal x to the power of the lowest exponent in the limit. Well, out of the exponents 1/2 and 3 over 2, which one is the lowest? Well, 1/2 is the lowest, so we know that we're going to let u equal x to the power of 1/2. So with that introduction of the new variable, we have an expression for x to the power of a half. And now we can move to step 3. We have to change all the other x variables. So this x to the power of 3 over 2 and this expression as x approaches 4 into the new variable u. So let's start off with this expression here, this x to the power of 3 over 2. So let's rewrite our general introduction that we made of the new variable u. How can we change this x to the power of a half to be x to the power of 3 over 2? Well, we can take both sides to the power of 3. Since we take the right side to the power of 3, we have to take the left side to the power of 3. And now notice how when we multiply these exponents, we got x to the power of 3 over 2, and then u to the power of 3 is just u cubed. So now we have an expression for this x to the power of 3 over 2, and that's equal to u to the power of 3. And what's remaining to take care of? Well, we need to find an expression for as x approaches 4, we need to find an equivalent expression as u approaches a certain value. Well, if x is equal to 4, if we rewrite u equals x to the half, our first introduction of u, then if x is equal to 4, then we know u is equal to 4 to the power of a half. So that means u is equal to 2. 4 to the power of a half is the same as the square root of 4. Square root of 4 is just 2. So as x approaches 4, that's equivalent to u approaching 2. And now notice how we have an expression for this expression as x goes to 4. That's the same as u goes to 2. And also notice how we have an expression for now all the x variables in the limit. We have an expression for x to the power of a half, which is just equal to u. We have an expression for x to the power of 3 over 2, which is equal to u to the power of 3. And we have that expression as x approaches 4, it's the same as u approaching 2. So then making those new substitutions, we have this brand new limit as u goes to 2 of u minus 2 all over u to the power of 3 minus 8. And we can just go to step 4 now and solve that new limit. So a couple things to notice. First thing, notice how our new limit is all in terms of u. There are no more x's left. Hence, we change the variable. So that's where the name comes from. And also notice how this limit is a lot nicer to work with than this one. There are no more rational exponents, and we can solve this limit with factoring because we can't make a direct substitution for the u variable as 2 because the denominator will be 0. 2 to the power of 3 minus 8 is 0. So then factoring that denominator, u to the power of 3 minus 8, that's a difference of cubes. So that's going to equal u minus 2 times u squared plus 2u plus 4. And as I mentioned in the overview video, almost always with change of variable, you're going to have to factor either a sum of cubes or a difference of cubes. And then notice how the u minus 2's will cancel out, and we're just left with the limit as u goes to 2 of 1 over u squared plus 2u plus 4. And now we can substitute that value of 2 for u. So when we do that, we would end up with a denominator of 12. So that is our final answer, 1 over 12. That's the answer for this limit that we got originally. Yo, what's up guys? Thanks for checking out my channel. Hopefully you got some value from the video you just watched. If you did get some value, big favor to ask you, please like this video and subscribe to the channel. Any questions, any recommendations on things you'd like to see, please leave it in the comments section. Also check out the description box below for links to material and content related to the video you just watched. Peace out.